Bismillahirrahmanirrahim. Assalamu alaikum. This is the second part of the lecture 12, in which we were discussing informed search strategy. We know that there are two main algorithms of the informed search strategy, which are greedy best first search and A star. The greedy best first search algorithm always selects the path which appears best at the moment. It uses the heuristic function and search for the goal. As discussed in the root finding problem from Era to Bogaraz, this search chooses the most promising node and not the path, as was the case in the uniform cost search. The uniform cost search chooses the smallest path, whereas the A star algorithm chooses the node which has the smallest cost. So in the best first search algorithm, we expand the node which is closest to the which is closest, and the closest cost is estimated by the heuristic function. Means that it chooses the node which has the smallest heuristic value, and therefore it is also known as greedy best first search. The greedy search need not to be complete, that is, there is always the risk to take a path that does not bring to the goal, and they may not necessarily detect the shortest path. Greedy search minimizes the estimated cost to the goal and thereby cuts the search cost considerably. Unfortunately, it is neither optimal nor complete, as we have seen in our previous lecture. Uniform cost search, on the other hand, minimizes the cost of the path, and so far it is optimal and complete, but can be very inefficient. So it would be nice if combine these two strategies to get the advantages of both. The A star algorithm was initially designed as a general graph search algorithm, and it is widely used in solving path-finding problems in video games and web-based maps. Because of its flexibility and versatility, it can be used in a wide range of applications. It is best known form of the best first search. It avoids expanding paths that are already expensive. It only expands the most promising paths first. Like greedy best first search, A star is also formulated with weighted graph, that is graph that whose edges has some numerical value. In A star search algorithm, heuristic as well as the cost of the path is combined to form the evaluation function. Let us consider the example of Era to Bogarast using the A star algorithm. Starting from Arad, it explored the three cities, and the evaluation function of the three cities is given. In the priority queue, the best evaluation function, the smallest evaluation function is of Sibiu, where 140 is the path cost and 253 is its heuristic value, which combines, which is equivalent to 393. So this means that the next city that will be explored using the A star algorithm is Sibiu. Cebu, in the priority queue of the Cebu, the Remnukvulcha is on the top, and so it will be explored next. From Rimnukvulcha, Pitisht is the city which will be explored next, as it is having the least evolution function and thus reaching the Bugarast. This is another example that we can solve using the A-star algorithm. The numbers written with the blue is the distance between the nodes, and the written with the red is the heuristic value. As we know that A star uses the evaluation function as a combination of path cost and its heuristic value to find the shortest path. So starting from A, it will explore two nodes, which is B and F. The evaluation function of B and F is 14 and 9. So the evaluation function of F is less than B. So in this algorithm, the A star will choose F as our new starting node. Now F is the new start node. F again has two nodes G and H. The evaluation function of G and H is 9 and 30. The evaluation function of G is less than H, so the next node will be G that will be explored next. G has only one node and its evaluation function is 8. So selecting I as the new start node, I has three nodes E, H and J, and their evaluation functions are 15, 12 and 10. It can be seen that the evaluation function of J is the smallest, so it will be selected as the new initial node. But we stop here as J is our target node. Students are suggested to try this algorithm using the A star. Students are suggested to try this graph using A star algorithm. Thank you.